So this is I think the first time that we are showing this slide, so probably not be as polished as we would like to be, but yeah. So basically, what we're trying to achieve. So we're talking about like world first PCB package design agent. Um, and when I say agent, I mean fully autonomous driving value for whoever want to do PCB and package design for complex packages, but complex PCBs. I think one of the key features and key, I would say, goals for us is to have a high confidence in the results that we're getting from this agent. Basically, we would like to get production level, let's say, confidence, production level quality. So, and I'm tell you what I mean. Okay, so if you're making a coffee, right? So you're telling your agent, make me a coffee. So it will put the coffee, it will put the hot water, and then it's gonna add white powder. Okay, so you don't want to discover that this was a salt instead of sugar, right? So it's not the same. As they both white, they both used in food preparation, and the folks love to add them to add flavor. So and in a similar way, but if you're taking the industry or production environment, you would like to avoid such confusion. So you would always want to know how this is being done. So this is one of our main, I would say, essential uh, um, items that we need to check with this agent. Um, the other thing, and those are related, so it need to be able to follow approved flows and act according to defined PKM. So methodologies, specification requirements, regulatory requirements, all those things need to be accounted. This is why it is very important for us uh, to define the flows that this is operates in. And with that, it still is flexible in making decisions, handling challenges, handling errors, um, and deciding what to do. Okay. In our case, we are looking at local deployment. So this is important for us in terms of security and kind of containing DIP and avoiding all sorts of threats. But in some cases, we do see a potential for kind of hybrid deployment or cloud deployment for certain areas. Um, uh, it is LLM agnostic to some degree, so we don't want to tie ourselves to a specific model for a specific vendor. This is not what it is about. It's about having a capable model, a reasonably capable model that meets your needs, that you can operate with. But this is always to a certain degree, so you cannot just add this to be like completely agnostic. So this is too much effort to do, but to a reasonable degree. The other thing, it's easy in adaptation. So the transition from our current situation, when it is human focused workflows to agentic environment, when it's the agentic uh, systems need to be, I would say, not as complicated as some of the other vendors suggest. So it has to be uh, a simple process that you don't have to be very software savvy in order to do that. So um, the other item that we are targeting is to have a scalable system, because once this is deployed, then there would be a lot of agents, thousands of different agents, different processes, if not hundreds of thousands, and maybe even more than that, that are running in parallel and working on different tasks, different projects, different aspects of the design. So this is very important to have a scalable system for a kind of multi-agent, multi-project uh, type of work. And it leads us to, it has to be cost sensible, right? So if you're using like millions of calls daily, so it has to be efficient in a sense of both kind of cost per operation, and the other aspect of that is the amount of data that is sent or transferred. So I believe that in this type of work, in this type of system, we're gonna see what is called like data gravity, not only between different data centers, like and consumers, but also within the system itself. So in other words, there is a certain cost on transferring data from machine to machine, from one process to process, and this need to be handled in a kind of large scale agentic system. So this is a lot of traffic. Um, and then the obvious things, it's gonna need to be secured, permissions, isolation, encapsulated capability. So all those nice things that we would like to have, and we would like to most of them address them by design. So this to be inherent to the architecture and the way that the system is deployed. So this is, I would say, what we're trying to achieve. I think in most cases, we are pretty successful in achieving that with our architecture and our, at least it's a prototype, but it's a fully functioning prototype. And I'm going to demonstrate some of those capabilities later on. Okay. Um, Now, if we kind of looking a little bit about the motivation and why are we investing in that, it's because we are trying to kind of adjust to the upcoming changes in the industry. So everybody's working on kind of adopting AI, adopting these new technologies, but really most of the big companies, they basically don't know what they are doing. So they're all over the place. I see all sorts of ideas. Most of them are kind of in this human-centric type of system. So when the AI is basically an assistant to an engineer, LLM-based tools for mostly non-essential functions. It's kind of nice to have, easier to work with type of functionality. Optimizers, advisors, agents that fetch data, summarizing articles, this type of kind of helpers, I would say, for the engineer. So this is happening today. I don't believe that this is gonna last long, because the next step, I think, that's gonna be an agent-centric system. So basically, when AI agent is gonna uh, handle the core functionality of the business, it's gonna be the center that drives value. So if we're talking about like package design, PCB design, silicon design, the agents gonna do this work that currently is handled by engineers. When where is the I would say points when we see that the engineers gonna dominate is setting the goals, setting the boundaries, and kind of outlining the desired outcome. So basically, you're expecting that you will uh, describe the challenge that you would like to solve. Okay, so this is how I see that this is evolving, and I think again this is gonna happen much sooner than people are expecting. Um, and so next week is a prediction as good as others. So, but I think that this is pretty much going in this direction. We see that in the software space, like software development space. This is very close to the actual folks that I would say drive this technology, develop this technology. So this is their areas of expertise. But as soon as it's pretty much operational, it's gonna propagate to other industries, other sectors. So we are very, I would say, aware of that. Uh, so yeah, so our focus is firstly on the ecosystem. So it's not gonna be a solution. It's not gonna be a framework. It's gonna be an ecosystem of solutions of different capabilities, different vendors, different uh, I would say frameworks. But kind of the easy part in an agentic system is as long as your agent is operational and it's know how to communicate with others. So it doesn't matter what how he was created, what type of framework, what type of I would say uh, language was used to kind of uh, to design him. So it's going to be an ecosystem type of solution. And the other area that we are focusing is how to make this transition practical. So in practice, right? So if you're saying, well, if people are suggesting, well, let's redesign like the entire company and let's change the way that people are thinking and operating, I think that this is not going to be happening. So we need to think about how to make this transition. So basically, those two things: first, the ecosystem, and then the transition. So in terms of workforce, I think I mentioned this. Currently, we are human-centric, so a lot of folks. There are some automation that is helping engineers. But it's really on the edges, so gonna and at least what we're predicting that once this technology is in production, the amount of agents is gonna explode. So the workforce probably will lose some of the numbers of employees, but I don't think this is gonna be as high as people are afraid of. Uh, but instead, the engineer is going to be a little bit more savvy in the relevant things. So the domain of expertise is going to change, and some of the workforce reduction, we're going to see that. But overall, I think that the amount of actors is going to explode, as well as the delivered goods, I would say, per company, per I would say, I don't know how to call it, an agent and an engineer. So per unit of production, or it's gonna be much higher than now. So basically, one engineer would the output is gonna be much more significant um, in terms of the delivered goods that he provides, right? And the other thing is that the cost per, I would say, delivered unit of goods is gonna decrease dramatically. So we're gonna see probably the same effect as mass production and Henry Ford kind of situation, when basically we have a smaller group that can deliver much higher capacity of outcome, and this means that the cost per one unit of outcome gonna be significantly less. And the reason why I basically could not achieve that with current technologies like what we traditionally have is that investing in automation, as complexity increases, is not providing you the amount of I would say increase in goodness. So the efficiency basically drops, and at certain point, this gonna the additional automation of the process is gonna reduce the efficiency. So at a certain point, the exceptions that you're getting, the debug sessions is gonna um, overflow, just making it manually with your two hands. So this is, I would say, this challenge is no longer gonna apply with the agentic system. We're gonna see that probably, but we still don't know when. Like probably the agentic system will have its own limits of operation. I don't know. What's gonna be. It's gonna be traffic. It's gonna be power consumption. Really hard to tell right now. But probably much more efficient than the traditional automation methods because of the flexibility, right? So when I'm talking about agents, I think we need to determine what it is that we're talking about, and I'd like to define it as what are the properties of an agent. It has goals, so you can define its mission, and it's gonna work towards this mission. Autonomous, so you don't need to be involved as an engineer to a certain degree, and it has to be flexible in solving these challenges on different unexpected, I would say, situations. And I would say the most important thing, it need to be able to use tools or derive goodness. So basically, it need to be actually doing something that gets you to the goal that you're trying to achieve, right? And usually this is done by reasoning loop. So basically, plan the next steps toward the goal, right? And then act, use tools, and then reflect, evaluate the situation, and see if this is uh, what is the next step. So it's gonna doing this loop all over again. Eventually, should lead you to a desired result or that you're trying to achieve if the capabilities that you assign to that are good enough for whatever you're trying to do, right? So, but this would be a very good agent. So there is some three different additional components that you need. One is you need to communicate with others because you need to be able to work with other agents. So one agent is not helping much. The other component is you need to have memory, short-term, long-term, and system operational memory in order to actually do something. So, right. And I think the thing that is most important for, I would say, production environment, right? So there's a difference in whether you're using that to solve homeworks or you're gonna mass produce 100 million chips with it, right? So it's different type of confidence. And in our case, you need to work according to expected flows, right? So if I'm giving it a task, I need to be 100% sure that the task was performed according to what I'm expecting it to do. So if I'm saying, well, you need to look at those process corners, it cannot skip one. So when you're delivering the solution, right? Okay, so kind of the ability to act, we see that as three big buckets. One is using tools. When I'm saying tools, I'm referring to software and tools that were designed for engineers, for humans. All right. Functions. So you need to be able to call a function, and it has to be able to, I would say, work with other agents. So ask or provide the requests, information, or any other interaction with other agents. So we see that as a skill as well. And memory, this could be long list of different things that you would like to consider when you're building your flows. It could be targets, goals, constraints, guidance, success metrics, knowledge base, um, system prompts, LLM availability, context windows stuff, project history, task sessions. So all those things, there is quite a long list. So basically, based on the need or based on the flow that this agent is kind of built for, you probably want him to have access to this type of data um, with a certain, of course, logic with a certain uh, properties. Okay, and if we're looking at communication with others, the handshake, I would say with the environment, we do see some solutions are popping up. Like the MCP is a very interesting one, but it's kind of intermediate solution. It is relevant now when a lot of tools, a lot of software is designed for human interaction, right? It's built for an engineer. But at a certain point, I think the importance of this type of, I would say, communication is gonna drop. Uh, so probably gonna see agent-to-agent protocols popping up. And there is the A2A and the ACP. that is rolled out, right? Still, we see that as kind of external protocols when you kind of at the discovery age stage, and when you want to see what type of capabilities or agents are there in the outside world, uh, external to your environment, your framework, your deployment. For internal communication, we see that the agent-to-agent protocols probably going to be something different, more like ACP. It's more like in this ACP type of direction, but it's not quite there. So going to be function calling happening a lot, and sometimes of different agent-to-agent protocols. So it's going to be something else that we still not sure what it is. But from the usage, from the experience that we are having, it seems that this is, yeah, not quite the uh, the communication standard that we're seeing. And yeah, we're saying agent, so I think this is the skills, the communication, cognitive capabilities, reflection. This is what we're referring to. And usually the memory stuff, this is database, maybe agentic database. So there is lots of solutions popping out in this domain. So lots of interesting technologies there. So yeah. And if we're talking about systems, so we're predicting that this is going to be more of hierarchical systems. At least this is the one that we are building. I firmly believe that at least for the first stages of this type of development, we're going to see systems that are resembling the, I would say, human teams in the organizations, because basically we know how to manage teams of engineers. We as engineers don't know how to manage and cope with a different structure. So um, we can definitely see that the user interface agent is going to be a separate entity with separate capabilities, not like the other ones. Going to be storing information about your past interactions, the teams that you're working on, the projects that you're working on. So this type of, I would say, memory, knowledge, and kind of guessing what you want to do, completing your kind of auto-completing your requests and your constraints and kind of the background that you're operating in. So probably going to be user interface agents as a separate, I would say, family of agents. And then I would say external vendors or tool vendors, such as Simbeor or any other EDA CAD providers. We expect that at a certain point, their tools are going to be agentic. So instead of just using a tool that was designed for humans, uh, gonna be using a tool that is designed for agentic operation. So because from our perspective, it doesn't make a lot of sense in training someone to use a particular tool. This is, I would say, a cost that is imposed on us as a user. So I don't want to train my system how to handle the different types of errors, how to correctly set the settings for, I don't know, stack ups, and I would say the right way to provide the parameters. I would like to have my system describe what is needed in more higher level of description. What are the requirements? What are the constraints? What are the technologies that I'm interested in implementing this? And this setting the environment and making it uh, uh, for instance, prepare the EDA software simulation in the right way with the right setup. This is on the tool side, I would say, on the vendor tool side, because I don't want to train my folks. I don't want to train my agents to cope with this. I don't want to have to deal with, I would say, error handling on a certain tools. So I would expect that this domain would be much more developing in the sense that it's going to be tool agnostic. So once this is agentic, there is no place for personal preferences, I would say. If you can design a schematic, then your agent is good enough, right? If you are able to run simulation for a transmission line, doesn't really matter who is doing that, right? As long as you are capable. So once you are transitioning to an agentic system, it's becoming much more tool agnostic. So I'm not sure how it's going to be played out, but this is what I'm sensing. Maybe the difference is going to be in licensing or business structures, agreements. I don't know. But like from purely engineering perspective, going to be much more tool agnostic. Maybe special capability is going to play more role, but then again, it's only at certain scenarios. Okay, and then the I would say our internal system is going to be defined from different agents that have different tasks, a different level of I would say complexity, engineering, and some of them going to be more towards task management or planning or purchase orders, I don't know, analysis, and some of them be very low level type of engineering work. So this is what I would trying to develop here. Okay, and in terms of communication between agents, so again, we're thinking this is going to be played out at least at first as a team structure in engineering organization. So you're gonna communicate with your team. If this is not enough, you're gonna communicate the issue to your manager or the agent that called you, and he will figure out from his team or his team of acquaintance of the different agents how to pass it down. So this is pretty much I would say the vision that we're trying to kind of work towards, and I think we're having quite good progress there. Okay, so this is the background, and in this demo, we will demonstrate fully operational multi-agentic system and the confidence level of its operation of the results or production level. So if I know that this system has been activated with the right flows, I have pretty much confidence in the results, so I don't need to guess. So it's, I would say, a deterministic in that sense. So the use case here is signal integrity analysis for post layout extraction, PCIe channels on PCB at sign-off stages. So it's the latest stage of PCB design when we're making sure that the design is compliant to whatever specification it is compliant to, it's designed to. And we're using Simbeor heuristic tool in our demonstration. So this is, I think, a result of long-lasting collaboration between my team and Yuri, and a lot of these capabilities, I think, is the enabler to that. So we're gonna define the mission for the agent, right? Then the agent is gonna run the analysis, do the extraction, and then generate a report. So it could be a different flow, but this is just something that we are gonna thinking that this is a good demonstration of the different capabilities here. So one of our basic agent is, I would say, an agent that is, would say, doing the orchestration and following the flow. So gonna get a request to perform a task, determine how the mission basically correlates to the flow, to his skills. He will determine what is the end goal, what is the delivery that he need to provide. If this is something from his skill set, he will select the one that is, I would say, providing or answering the request. And then he's gonna identify the path in order to achieve this goal within the workflows that are supported, approved, or defined for this agent. So it's gonna stick to the way of how this is expected to be resolved. Then he's gonna execute and monitor the flow. Okay, so he's gonna check if the flow is executed in the right way, validate the results, and pass up the results or errors or whatever. So basically, I would say the question that we are trying to answer and this reflection algorithm is not how to do things, but whether what to do next. Okay, here's your state. Okay, what is the next step to achieve the goal? Not how do you need to achieve the goal. So the how question is, I would say, almost forbidden. So to like minimize to a certain level of operation. So I think I'll give Josh uh, to take it from here, maybe explain a little bit more on how this is constructed. He's our the AI expert for my team, so I think this is a lot of the solution. He is the author of some of the key I would say properties in here. So Josh, you wanna?
So thanks, Alex. I've built the system that we're working on here around different classes of agents. So it's all child classes of different base blocks. I have an AI agent class on top of which I build a taskmaster agent, which is a more specific goal-oriented type of agent. And then from there, I develop more children for specific tasks. So the general idea of a task master is he has capabilities. He'll have a list of functions that's actually just contained in an Excel sheet, formatted like you see on the slide. Uh, it's just a few parameters, the ID of all your functions, the name of the functions. Type just changes a little bit about how it runs, but it's not too important. And then the description and tags is what's relevant for the LLM. So when I ask a taskmaster to perform a specific task, he can then parse based upon the description and tags. Oh, you want to do this, and he'll figure it out. What's your final end goal? And then using the dependencies column, this is outside of the hands of the LLM at this point and is built more into the state machine. It determines, oh, in order to do the last task you see there, the S0101, you require that the state of L0101 is going to be 1. And so you can see the little state machine diagram above there on the top right, which shows how the dependencies are mapped, and there's optional dependencies, hard dependencies, and we're looking at adding additional functions for mapping interdependencies across higher levels. But the very basic flow is, in order to run the final end goal, you need to make sure that its dependencies are run. And if they're already run, then their dependencies don't matter. But if they aren't, then you need to check their dependencies and go all the way back through the chain until you reach a starting point that can be considered from scratch, like what an open node is. And quite often you'll enter into this from another taskmaster. So in this case, sign-off taskmaster is a more higher level taskmaster. And 3 of his functions are calling lower level taskmasters. Call project start creates a taskmaster to manage a lot of the inputs for the process. Call Simbeor extraction performs the actual extraction in Simbeor and validates certain steps along the way. And then call sparam report is another agent for generating reports and PowerPoints. Alex, do you want me to demo on the live, or should we go through the presentation?
Let's, I think, start with the presentation and then can show some actual live demonstration.
So you could go on to the next slide then.
Yeah. So
this is the general layout of the sign-off taskmaster. So any taskmaster can have its own structure built just by creating an Excel sheet. They can have additional functions added to them, but the base idea of a taskmaster, you just create an Excel, you're good to go. It doesn't mean that he has a task yet. He has capabilities. In order to give him a task, you have to ask him something. Give me a report. So in this case, the rightmost diagram shows I've asked for a report. It gives a star. Oh, you want this function over here? Call sparam report. And so if we go to the next slide, it will identify, it's mapped in yellow, call project start is the step it needs to go, and that's calling another agent. So over here, it adds the state diagram for the secondary agent, and he's going to try and find project name, select the board, select the stack up, select nets of interest, identify the compliance specifications, analysis type, I mean, which one is for this specific nets, and then that's wrapped up. It's that step is considered done. So if we move to the next agent, so call project start is now done. That node is completed. And then we verify the inputs of that node in the next one. I think a good way for every taskmaster, they should have the ability to check that their inputs are good. Ideally, they should be, but a taskmaster should be verifying its inputs. And then after going through a few steps here, so it writes the instructions. This is using Lua scripting, which Simbeor has for extraction. It's something that they added a few years ago. And so opens the Simbeor, loads up the instructions, runs the extractions, and then the last step of that agent is just taking the S parameters and putting it into a folder ready for the next guy. Here, this guy takes the analysis, creates the template according to predefined, based on what type of analysis we're doing. It runs certain graphing functions, generates the PowerPoint, and there we have it. And so it's a system that uses multiple agents, multiple taskmasters, with the one on top managing his lower workers, and it's passing information up and down the chain between them. Yuri, I believe I showed you this this flow with a single agent a couple weeks ago.
Yes.
So it's a similar flow now. The difference is it's using multiple taskmasters, whereas before it was a single taskmaster with his own flow and it was a single call. Now we've upgraded it so that it's with multiple task masters and one that is performing agent orchestration over all of them.
You
So,
wanna show the demo?
yeah, so
Yeah, okay, so once you're ready.
yeah, so I'm sharing my screen over here. So just a few lines here where I'm booting up the taskmaster. I just create an instance of it in MATLAB. So these are just base methods of the taskmaster class: create graph and refresh state colors, just to show what it has. It can also load states, save states, and receive states from other agents. But in this case, states are all zero because it started off and it has no goal, it has no vision, and that's where we're going to give it now. So just from a pop-up, I'm going to say create report. And so now this is going to the LLM. It's going to think a little while, and it's going to realize, oh, you mean this step over here. Hopefully. I mean, I have temperature pretty low, so it usually gives the same response most of the time. It's taking a second. Yeah, it's running. Just not plotting it. Oh, there we go. Okay, so it identified this is the step to do, and in order to do this, it needs to first run this. And inside of the Excel, there's a precedence for which dependency to run in which order. It can be redefined. It's something that we're looking at, giving flexibility for the LLM in that respect. I think dependencies should be hard coded. If something requires a dependency, we know when we design the scripts, this is needed before getting to this point. But if we have optional dependencies and multiple choices, I think that's the kind of freedom we could allow the LLM to know. Oh, if you're trying to do it in this way, then maybe try this one first. So in this particular case, the start project is a hard-coded initiation, and this one is agentic, the call project start. So I told it to give precedence to this one, and so now it's booted up this agent here. It's done its start project, and it's asking me to pick its board. It has an alternative option where it gets the hard-coded version. So I can actually cancel here. I don't pick the board, and it's able to use this backup function in order to do it. So each one of these optional dependencies, if the first option fails, it can try another, and we can build up modules and many different functions to do each of the end goals we need. So here I pick the stack up, the net list, and he does some other processes internally, and he's done. He's determined that he's finished his goal. So that's moved on. It's moved into this guy. He's now trying to achieve his goal. Doesn't require any user input at this point. But he boots up Simbeor. And so all of these steps inside of here were dependent upon information passed from this guy. So it goes from this guy up to the top and then back down again. We are looking also potentially passing direct from one to another, but I think for the most part, it makes sense to pass up the chain to the orchestration and then back down. And so over here, Simbeor is just about done running. It's very quick extraction, low resolution, just for a demo, but it's done already. Extracted 8 differential nets. And over here, it took the S parameters and passed them to this other agent. So this other agent is now performing plots according to, I have predefined a template for PCIe for this specific analysis, but that's something else that the agents can then decide between them based upon what you've chosen. It chooses which template to run. It can then look at the entire library and determine which one is the most fitting for your particular run case. And here at the end of the process, I now have a PowerPoint ready. So this is a flow that I personally have had to do for sign-off. It's something that takes a while, and especially when verifying different steps having completed correctly. So the agent's taken over one of the jobs that I've done in everyday life. And it's monitoring success, and yeah, it can also
Yes.
be.
So this is the good thing is I would say the trust that I can have in this type of agentic systems, um, and I think this was one of the missing things that we have so far in coping with different AI solutions. So this is very important for us. It's a multi-agent environment. So in this example, this is just example flow. So the actual, let's say, process can be much more complicated, more sophisticated, and then adjusted per need or per what you're trying to achieve. But I think we demonstrated the, I would say, tool usage, state tracking, hierarchical orchestration. It runs locally with pretty much old GPU, so doesn't have to be very sophisticated, very capable in that sense. It's very, I would say, easy to adopt. It's easy to set up. So basically, um, an Excel table with kind of things that he needs to take into account when he's selecting his skills. Basically, a rough description of what is capable. It's enough. Like you don't need to be very particular on what it is that you're trying to achieve. So if this is kind of reasonably close, this is fine. So um, and there is the flexibility. You don't need to be the software engineer in order to set this up. So you can just easily translate your script, your work to this type of documentation. Okay, so I suggest let's set up another meeting, and we can talk how we can collaborate. Where is the best way that we can, I would say, connect the two